Have scientists actually created life? This video explores the current state of synthetic biology, detailing the cellular synthesis, DNA engineering, and modern laboratory analysis techniques used to study life's fundamental processes. What does creating life really mean? It ranges from building an organism from scratch to copying existing life, modifying organisms, or even attempting to reactivate dead cells. Each approach presents different levels of complexity and technical challenges. To understand life, we must define it. Life is typically characterized by metabolism, reproduction, evolution, and the ability to respond to environmental stimuli. These fundamental pillars allow us to study biological systems more effectively. How did primitive life arise? The theory of abiogenesis proposes a path from a primitive Earth through chemical evolution, leading to early biological development and the emergence of the first self-replicating cells. The classic Miller-Urey experiment demonstrated how basic organic molecules, specifically amino acids, could form under conditions simulating a primitive Earth, providing a foundational step in our understanding of chemical evolution. The RNA world hypothesis suggests that RNA played a critical role in early life, acting both as a store of genetic information and as a catalyst, known as a ribozyme, to accelerate essential chemical reactions. So what can scientists construct today? We have made progress in creating simple synthetic structures, such as lipid membranes, vesicles, and early components capable of self-replication. In 2010, Craig Venter and his team achieved a milestone by successfully creating a synthetic genome based on the bacterium Mycoplasma mycoides, marking a significant step in synthetic genomics. Was this a truly, quote, artificial organism? There is ongoing debate. While the genome was synthesized from scratch, the experiment relied on a pre-existing natural living cell as a host, highlighting that we have not yet created a fully artificial organism from raw components. Today, our capabilities in DNA synthesis continue to grow. We can synthesize viruses and simple bacteria, design genomes from scratch, and we are constantly developing more advanced methods for creating complex organisms. Synthetic biology has practical applications in many fields. In medicine, it aids in vaccine and drug production. In the energy sector, it helps develop biofuels and creates new metabolic pathways for industrial use. Can we create a cell from scratch? The answer is still no. While we can integrate synthetic elements into living cells, building a completely new cell remains a profound scientific challenge. Science still faces major hurdles. The primary challenges in contemporary biology include understanding the origins of the first genetic information, the first metabolism, and the first instance of self-replication. Despite the challenges, we have achieved much. Researchers have successfully designed and synthesized a complete bacterial genome, performed a successful transplant into a living cell, and produced a functional, replicating organism. In conclusion, while scientists have learned to design and modify life, we still cannot definitively demonstrate how the first life arose on Earth. It remains a central mystery of our origins. This video relies on a foundation of diverse scientific literature. We have gathered resources in multiple languages to provide a comprehensive look at the topics discussed. Our research process involved consulting academic publications and popular science sources to ensure accuracy regarding abiogenesis, synthetic biology, and the origin of life. The following slides provide a bibliography of the key works used. This includes influential books by authors such as Nick Lane and Paul Davies, who offer deep insights into these complex subjects. We also referenced fundamental scientific papers, including the historic Miller-Urey study from 1953 and more recent advancements in genomics by researchers like Craig Venter. Additionally, reliable online sources such as NASA Astrobiology, Nature, and Science were essential for gathering the most current information and data. These materials are presented here to encourage further exploration for anyone interested in the science behind the origins of life. For those seeking more details, these references cover everything from the basic principles of chemical evolution to the latest breakthroughs in synthetic laboratory techniques. We have organized these sources to be accessible to both students and science enthusiasts alike, ensuring a clear path for independent research. Thank you for engaging with this overview. By studying these materials, you can gain a deeper understanding of the scientific progress and mysteries surrounding our existence. We hope this bibliography serves as a valuable starting point for your own journey into the fascinating field of evolutionary and synthetic biology.